Hi all, my name is Divya Talla and I am currently pursuing Masters in Data Science and AI from the University of Liverpool. In today's video I would like to take you through the concepts of slope and gradient and understand their applications in real life. Let's hear a conversation first.
Hey Divya, how was your skiing adventure?
Hello, Les. It was adventurous. I perfectly did a blue slope, but the red one was real tricky as the gradient range crossed 25%.
Whoa, hold on. I didn't understand a thing of what you said.
It's okay if we are all in same boat as Les. By the end of this video, we will all be able to understand what Divya was trying to say. Let us understand what slope or gradient is. It is a number which tells about both the steepness and direction of a line. The steepness is measured by the absolute value of the slope. Larger the number, larger the steep and vice versa. The direction of the line is either increasing, decreasing, or flat. A positive slope determines an increasing line and negative determines decreasing one. Having a slope tells us that the distance is covered both horizontally, also called as x-axis, and vertically, also called as y-axis. Slope is the change in vertical distance over the change in horizontal distance. If we are moving from point x1 y1 to point x2 y2, then the slope is given by the formula y2 minus y1 over x2 minus x1. For example, if we move from point -1 minus 2 to 1 and 2, then the slope is 2. Let us understand the concept of secant and tangent lines. A secant line is the one that intersects a curve at 2 points. It represents the average rate of change of the curve between those 2 points. Slope of a secant line is straightforward. A tangent line touches a curve at a single point without crossing it. It represents the instantaneous rate of change or slope of the curve at that specific point. To calculate the slope, let's assume the 2 points on a curve where the distance between them tends to 0. So the gradient here is a limit function where the distance, h, between the 2 points on the curve tends to 0. Let us see a mathematical example. We need to calculate the slope of the curve x squared plus 2 at point 2, 4. Slope is given by the limit function as we have seen. Substituting in the above equation we get the slope as limit h tends to 0 f of 2 plus h minus f of 2 divided by h. Solving the equation we get the slope as 4. So the slope of the curve x squared plus 3 at point 2, 4 is 4. Let us understand some real-life applications of slope calculation. One major use case of slope is while construction of roads. It is a critical factor to consider for safety, efficiency, and stability of a vehicle, especially when it must ascend or descend a hilly terrains. For example, let's assume that we are designing a straight section of road which should give us a horizontal run of 100 meters and vertical rise of 20 meters. Using the formula, the slope in percentage grade would be 20%. The understanding of slope in this context plays a crucial role in creating infrastructure that meets both functional and safety requirements. This is a simple example for conceptual understanding, but it is important noting that real road design involves more complexity by considering factors such as terrains, curves, and intersections. Similarly, the concept of slope grade is also used to understand rainwater accumulation, cut and fill calculations, erosion control, etc., during road construction. Slope calculations play a significant role in the design and operation of roller coaster rides. Engineers carefully consider the slopes of various sections of the track to ensure both safety and a thrilling experience for the riders. Few use cases where it comes handy are sloping of initial ascent. The coaster is taken to peak point and the slope of the climb determines how much potential energy can be gained by the coaster. With more incline, more energy will be gained by the coaster, and it gives the thrill of the ride. Similarly, the slope of the drop affects the speed of the coaster. So engineers use the slope angle to get desired speed. Similarly, this calculation used for banking of the turns, twists and inversions, designing braking systems, etc. So in conclusion, we understand that the slope calculation serves as a foundation for many of the real-life applications. Throughout this video, we have understood the concept of slope, secant and tangent lines, and understood how a simple mathematical concept is used as a powerful tool by engineers in fields of construction and entertainment sports. Thank you for watching.